Greetings and welcome, friends. Talking about surface area volume. Joshua, we're talking about volume of spheres. That's a crazy solid. Is that a polyhedron, friends? No, it is not a polyhedron because it is not made of polygonal faces. So in order to find the surface area of a sphere, the surface area of a sphere formula, here's my little surface area of a sphere symbol there, is 4 pi r squared. Now they happen to give me the circumference of the great circle. And circumference formula, perhaps you remember, is 2 pi r. Lauren. This is a circle, so... Yep, it doesn't matter if the circle's on a sphere or on a plane. Don't matter. So I know the circumference. I want to find r so that I can then plug that r into this formula here. That's my general strat for this problem. So if 2 pi r is equal to 4 pi, I can solve for r by dividing both sides by 2 pi. And r is equal to 2, measured in feet. Linear, bless you. And if r is 2, now I can plug that in up here for surface area. So yeah, 2 squared is 4, times 4 is 16 pi. And that would be measured in feet squared. I'm fine with that. I feel like I would be safer if there wasn't school tomorrow. More review. So, all right, Lauren, let's keep going. Find the radius of a sphere with a surface area of 4 pi. So now I'm just gonna plug that into that formula. Surface area is equal to 4 pi r squared. I feel like my pen is writing a little thinner than normal. That's all right. So 4 pi r squared is equal to 4 pi. And solve for r. Divide both sides by 4 pi. R squared is equal to 1. Root both sides, plus or minus, don't forget it, but then forget the positive negative 1 anyway because this is geometry. So r is equal to 1. And this radius, Isaiah, would be measured in what units? 1 times 1 is 1. This would be measured in just plain old feet, because a radius is a linear dimension. All right. Oh, here we go. Getting interesante. Find the volume of a sphere. The volume of a sphere was 4/3 times pi r cubed, Joshua. So, I've got to find the radius. Guys, radius for this formula. What is the radius for this sphere? Joshua. I like it. How'd you find that? I like it. I like it a lot. So the volume is going to be 4/3 times pi times 11z cubed. Oh, it's all times except for that 3 down there in the denominator, as I call it. So let's see. 11 to the third is 1331. By the way, 11 is a number that happens to have multiple palindromatic perfect squares, squares, cubes, powers. There we go. Wow. So 1331 multiplied by 4. It's going to be 5,324 divided by 3 pi. And this is going to be measured in yards cubed. All right, I can't reduce that fraction. And how did I know I couldn't reduce that fraction? Does anyone know how? How did I know 11 cubed? And 3 is a prime number, and cubing 11 will... That, like, its prime factorization is just 11, 11, 11, and those cannot be divided by 3. So I didn't even need to bother trying to reduce that. But you can get a decimal approximation of that, multiply that by that numerator by pi, and then divide by 3. Give me as many exact answers as you can. So there's a decimal approximation. Let's see. Okay, yep. Let me go back. Okay. So here we go. Let's take a look at this one. Here we want the volume. They gave us the surface area. So I'm going to say 4 pi r squared is going to equal 16 pi. We'll solve for r and then plug that into the volume formula. All right. Sorry. Divide both sides by 4 pi. Isn't that convenient? R squared is equal to 4. Root. Malik, what is the square root of 4? That's 2. That's 2. So r is equal to 2 or negative 2, but since we're talking about a radius, we don't consider that to be a negative number ever. So the volume of this same sphere is going to be 4/3 pi times that 2 cubed. 2 cubed, in case you guys didn't know, is 8. And 8 times 4 is 32, so it looks like 32. That's I'm going to give a better 3 for that one there. 32/3 pi. Measured in feet. If this is in feet squared, being surface area, like the amount of paint it would take to paint that sphere, the volume is going to be in feet cubed, which is answering the question right. How much could fit inside that sphere? So 32 pi divided by 3. That sounds right. 33.51. And yeah, I'm happy with 2 decimal places from you guys. Feet cubed. I think I've got one more question for us. Oh, the ice cream cone. Snow cone. There we go. All right, I'm thinking this plus this is going to equal the total volume. Volume totes. Totes. So, and actually that's a good question. If a full sphere is 4/3 pi, it'll just be, 2/3. Or you can divide 4/3 pi r cubed by 2 at the end. And the volume of a cone is that. As far as these dimensions, this is 6. Therefore, this radius is also 6. How high is this, by the way? Also 6, yeah. And the height of this is 12. Do I need the slant height? No, not for volume, friend. I don't. But I could find the slant height if I wanted surface area of that cone by using Pythagorean theorem. So let's see. There's the setup. So 1/3 pi times 6. Wait a minute. I missed my h. Guys. Joshua, you're supposed to help me here. I missed my h. All right, 6 squared multiplied by 12. Over here is going to be 2/3 with the pi times 6 cubed. I think 6 cubed is 216, if I'm not mistaken. All right, 6 squared. All right, I'm thinking of how to cancel this cleverly. That's going to be 36 times 4 if I reduce. Let's see. Right, 3 goes into 3 once and into 12 4 times. These are not like terms. So that's why. Because this is a 6 squared, that's a 6 cubed, and that had a 12 on it. So let's see. So I'm going to have 6 squared times 4, 36 times 4. This is 144 pies. And over here, 6 cubed is what, 216? Divide that by 3 is 72 multiplied by 2. Wait a minute, these are the same? because this is a hemisphere. It wasn't the full sphere. Right, Malik? Joshua? You guys with me? So I get 288 pi. That's actually weird. These both happen to have the same volume. Isn't that weird? I think that's weird. And that would be measured in feet cubed. So there's exact, multiply by pi to get a decimale approximation. 904 point... Nope, 904.78 feet cubed. Thanks for watching, Internet friends. It's been a great semester.